Hello everyone. So today we study about the process state in the operating system. So the process state is used to find out the status of the process, that is whether the process is executing in the CPU or whether the process waiting for input output resources. So various states are used in this, that is the new state, ready state, running state, wait state, terminate completion state, suspend ready state, and the suspend wait state. So understand this the concept. What is new state? So in the new state, the process is to be created, or we can say the process is under creation. And in the ready state, the process is already created, and that process is to be moved from the new state. In the ready state, the processes are waiting for their turn for executing in the CPU. In the running state, the process is executed in the CPU, and in the wait state, the process is waiting for input output resources. And in the terminate state, the process has already completed their task, and after that the process is terminated through the terminate state. And in the suspend ready state, if the resources are not sufficient in the ready state, then that process is moved to the suspend ready state. And in the suspend wait state, if the resources are not sufficient in the wait state, then the process is moved to the suspend wait state. Now understand this state, that is a suspend ready state. For example, we have processes in the ready state, and there is no space available in the ready state. Now the process is coming from the new state. Now there is no space available in the ready state. Now this is the problem. So in that case, we have to move that process into the suspend ready state for wait for some time, so that when there is space available in the ready state, that process that is available in the suspend ready state is to be moved to the ready state. So this is the concept of suspend ready state. Same is the case in the case of suspend wait state, where there is no space available in the wait state, and the process has to be wait for some time in the suspend wait state. So when there is space available in the wait state, that process is to be moved from the suspend wait state to the wait state. So this processes are 7, the states are 7. So the new state is in the secondary memory, residing in the secondary memory. And when the process in the ready state, running state, and wait state, it means that the process is residing in the main memory. And when the state is terminate, suspend ready state, suspend wait state, these state are also residing in the secondary memory. Okay, so keep in mind that the new state, terminate state, suspend ready state, and suspend wait state residing in the secondary memory. Okay, so understand this state concept with the help of diagram. So in the new state, this is the new state, the process is created, and after creating, the process is moved to the ready state. In the ready state, they are waiting for some time for their turn, so that they can be executed in the CPU. And when the CPU is free, that process is moved to the running state for their execution. Okay, and if that process is want some input output work, that is printing some work, so they have to move to the wait state. That process to be moved to the wait state. And again, if that completed their task of input output, that is to be moved to the ready state. After that is to be processed in the running state, and finally is to be terminated. Now when now understand the concept of suspend ready and suspend wait. So when the process is coming from the new to ready state, and in the ready state there is no space available. Okay, so that process move to the suspend ready state, and when there is space available in the ready state, that process move from the suspend ready to ready state. Now understand the concept of suspend wait. Now the process is move from the running state to wait state. Now there is one process is coming from the running to the wait state, and the wait state is full of processes. So now what we have to do, that process is to be moved to the suspend wait state for waiting for some time. Okay, and when there is space available in the wait state, that process is resume to the wait state, and after that ready state, and after that the running state, and after that the process is to be terminated. So this diagram is the preemptive state diagram. So understand this concept of preemptive state diagram. So what it means, preemptive means the process is preempted for some time, or you can take the word for preemptive, that the process is exit for some time. Suppose we have two processes, P1 and P2, and P1 required 4 millisecond for its processing, and P2 requires 6 millisecond for its processing. So in the starting, I assume that each process I am going to give the equal time for the execution. So I take the time quantum is 2 millisecond. It means that when the process is executed for 2 millisecond, I preempt that process, and that process to be moved to the ready state. This line is indicate that. And after that, in the running state, I assign the second process, that is a P2, and P2 is also executed for 2 millisecond time, and that process is also preempted and goes to the ready state. In the ready state, again I pick the process P1 because the 2 millisecond is left in the earlier. So I again P1 assign to the running state, and after that for execution done for the 2 millisecond, and that process to be terminated. Okay, now again P2 I have to assign it to the running state because the 4 millisecond is left for the process P2. Now the P2 is to be processed in the running state, and when it is executed for 2 millisecond, I again preempt that P2 process from the running state and move it to the ready state. So again 2 millisecond is left. So again I scheduled the P2 process from the ready state to the running state, and after executed for the 2 millisecond, the process P2 completed their task and it is terminated. So this is the main task of the preemptive state diagram, or this line indicated the time quantum expire. When the time quantum expire, that process to be moved from the running state to the ready state. So next is the non-preemptive state diagram. Now you can understand easily what is non-preemptive means, that the process is not to be preempted. Okay, so this line here in the previous diagram I have assigned indicate the line, that is the time quantum expire. In this diagram I didn't mention that line. So this is the non-preemptive state diagram, and rest of the state diagram or the states are working are same. So this is all about the process state in the operating system. So please subscribe, share and like the video. Thank you.